So in this problem, we're given a cable spool with a couple different initial conditions, and we're asked to find the frictional force between the spool and the ground and the acceleration of the mass center of the spool. So first, let's draw our free body diagram. So we have our spool here, and then we have a force due to gravity acting on the center, and then we have these two different radiuses. So this first one is 4 inches, and the larger one is 8 inches. And then we have a force of friction acting opposite the motion. So our force of friction is going this way. And we also have a normal force acting up, which is opposing the gravitational force. And then we also have this tension force, which is 50 pounds, acting on this smaller radius. And then we have our acceleration, our angular acceleration, and our acceleration in the x direction. So from here we can write out our free body, or our equilibrium equations. So we have the net forces acting in the x direction. So we have this force of 50 pounds acting to the right, acting to the right, so it's positive, minus the frictional force that's acting to the left and therefore negative. And then we have, this is equal to our mass times acceleration, and mass in this case, since we're given a weight of 50 pounds, we want to convert this to mass, so that's just 50 divided by 32.2, and this is acceleration due to gravity in feet per second squared, and that's going to give us the mass, because weight is equal to mass divided by gravity. Or sorry, our mass is equal to weight divided by gravity, and then that times our acceleration in the x direction. And then it's also important to note we're given our I value in the equation, which is 0.28 slug times feet squared. So we're also going to take our sum of the moments at the center of the spool, which is equal to the, we have the moment acting due to the tensional force, and so that's going to be 50 pounds, because that's the force, times the radius, and it's only acting on this smaller radius. So that's going to be 4 over 12, and this is just our conversion of inches to feet, so it's 4/12 of a foot. And then that is equal, or that is, we subtract our 8/12 times the force of friction, because the force of friction is acting the opposite way of our tensional force is acting to the left, which is going to create a negative moment, and that is acting on the entire spool. So that's our 8/12 of a foot, because it's the 8 inches of the whole spool. And that is equal to our I value, so that's 0.28 times angular acceleration. This is just our I value, and we're just plugging that in. Okay, so from here we know that the spool is also rolling without slipping. When something is rolling without slipping, we know that our acceleration in the x direction is equal to the negative radius times our angular acceleration. And our radius for this spool is equal to 8/12 of a foot, and that's times our angular acceleration. And then, so we can we can plug this into our forces in the x direction. So when we do that, we get 50 minus force of friction is equal to 50 divided by 32.2 times negative 8/12 times angular acceleration. And that simplifies to force of friction is equal to 50 plus 1.0352 times our angular acceleration. And then we can do the same thing for our moment equation. And here we can plug in the frictional force that we found, that we solved it for, and the net force in the x direction. We can plug it in to here. So that ends up giving us 16.6. Here, I'll write it out. We can do, it'll be 50 times 4/12 minus 8/12 times 50 plus 1.0352 times our angular acceleration is equal to 0.28 times that angular acceleration. And we can simplify that, and that is going to give us 16.667 minus 0.667 times our frictional force, 50 plus 1.0352 angular acceleration is equal to 0.28 times angular acceleration. And then when we combine like terms, we get negative 16.667 is equal to 0.9701 times angular acceleration. And then from here we get our angular acceleration is equal to negative 17.18 radians per second squared. So we can plug this back into our frictional force equation. So when we do that, we get frictional force is equal to 50 plus 1.0352 times negative 17.18, and we get our frictional force is equal to 32.22 pounds. So the last part of this problem is finding the acceleration in the x direction, and we know that acceleration in the x direction is equal to negative radius times angular acceleration, and our radius was negative 8/12 because it's the radius of the whole spool, times negative 17.18 radians per second squared, and this gives us our acceleration in the x direction is equal to 11.45 feet per second squared. And then those are our final answers. We solved for the frictional force and the acceleration in the x direction.